All right, guys, I wanted to show you something. So I was having a hard time getting the proper distance from for the maglev to go in here. For some reason, when I set up the new one, it wasn't working. So I decided to go with a smaller magnet. And what I needed to do was, so I have my carbon fiber rod. I printed out this little piece here that has a little hole for the bearing, a sleeve part for the magnet, and then a part that fits in perfectly in the end there. And if I show you this one, the magnet goes on here. It then slides onto the sleeve nice and hard. And then this goes in there like that. And that's also nice and hard. So this is completely self-contained. And I believe it's the perfect distance because in all of my research, either the magnet either has to sit proud of this, of the ring magnet. It has to either sit just proud of it or just proud inside. So yeah. But I think the problem was I was using too big a magnets, but then that didn't really make sense to me because the old rod that I used was much bigger and it had the bigger magnet on it. I was using a rod this big, which is this one is like 5 millimeters and this one's like 10. And it was working fine, but I'm not sure what went wrong. So I'm redoing all this. I reprinted out these. Like I said, that little ball bearing, I even tapered the end there, will fit perfectly in there, and it should work. So I've got them all printed out. Let me get another bearing. I'm using these smaller bearings, and they fit perfectly in there, which I'll obviously glue that in there, but you can hear how nice and tight that is. And then the magnet sits on this sleeve right here. So let me see if I can get it together and try it out and see how it works. Stay tuned. So a little heads up, I figured out what I was doing wrong. So for the maglev, like the old style where the magnets are on the outside, you use 3 magnets to support the magnet on the rotor. You have to do it north, 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 or south, 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 south on each side. Where the magnet facing out was north and the magnet facing out on the end of the rod was also north. With this, it's the opposite, and I completely forgot about that. That's why it didn't work. But that mistake caused me to redo this, which is really good, which is much better than the other setup I had. The other setup I had was this thing with glue, and so the mistake actually helped out. But that's what it is. So this has to be south facing, and then the magnet, the ring magnet, has to be north facing. So what happens is when I put this into the ring and I get past that pushing point, it then drags it against the wall here. It drags it against, here, let me fix this so you guys can see what I'm talking about. Once I get past that pushing point and I go in like that, see, it then captures it perfectly. And actually what I'm going to do is I'm going to reprint it so that it sticks out a little bit more. But yeah, so the mistake actually was a blessing. Stay tuned. All right, so here, I'll show you the proper distance that I want. So if I take this and I push it in, that's where I want it. Where it's just shy of, it's almost level to this outside ring magnet, but you can see it's perfect there. It doesn't want to wobble. Before it was hitting and sticking on the other side. I'm like, what am I doing wrong? Turns out I had the magnets reversed. Okay, stay tuned and see what's great about the way I designed these maglev ring magnet housings or holders. I didn't glue this back plate on. I screwed it on so I can take it out and put different backings in. Like I'm going to use this. I put a glass one like this inside that one there, and it works perfect. And I'm going to do the same with this one. Stay tuned. All right, there it goes. Fits perfectly in there. And it's captive exactly the same on both sides. I don't think there's any play. Oh, there's a little bit of play, but that's okay. That's why I have this adjustment nut. And so it was funny because I was thinking last night, and I do a lot of my best thinking when I'm sleeping. I kind of dream of stuff. I want to try these. Maybe I'll even do it with this one, or I'll do it with the magnets that I got from the larger one. These are, I think, 3-inch magnets. I'm going to do the same thing. I'm going to build out a rotor, but I'm going to do it vertical. And I'm going to do it vertical like the other maglev that I have, which is a vertical one. I want to see how that works. And what I want to try to do, I know it's probably going to be really hard, but what I want to try to do is, I know I can balance the bottom portion of the maglev just by using 2 magnets in repulsive mode. And so normally what I do for the top part of the rotor stem, I'll just capture it with bearings. But I don't want to capture it with bearings. I want to capture it with magnets. So I know if I just do something very similar to this on the top, it would work except for one thing. It would kick the bottom out. So I would need another setup like this towards the bottom so it won't kick it out. And I'm thinking I can do it with these ring magnets in such a way where you notice how this is captured by, so the South Pole, so the North Pole's on this side and the North Pole's on this side, on both of these are facing out. That's what I had forgotten about. I can do the same thing, but in a vertical situation where instead of this pressing up against glass, there would be another magnet here. There would be 2 magnets here in repulsive mode, pushing against it really tight. It's kind of hard to explain. You probably get where I'm going with this. But I'll turn this vertical, and the bottom part will be no big deal. The top part will be the same as this, except in an opposite way, where it'll be pushing against the bottom magnet here. And in that way, I should be able to capture the rotor completely with magnets, using no glass, no bearings, no nothing. It's going to be a little tricky to figure out, but I think I have the setup already. I just need to modify it. But first I want to get this guy going. You can see there's a little bit of a wobble to it. I'm not sure what's going on with that. I think this carbon rod is not true. But we'll find out. Stay tuned. So I did all that work just to find out that I don't have a coil thin enough to fit underneath there. Yeah, that's too tight. That's too tight. What I could do is cut a hole in this plexiglass or just put one of these underneath there, but that would be way too far. But out of all the coils I have, and I got like a bazillion coils, I don't have a single one. Oh, wait a minute. Yes, I do. I believe I have, if I could find it. Aha. Oh, that's mine. That's the junky one. I know I have a coil, a pancake coil, a Sky Collection pancake coil. I gotta find it. Dagnabbit. And I could also, instead of running it underneath there, I could just run it like this. But I don't like doing that. Anyway, let me see if I could find, I know I have that pancake coil, and I believe that pancake coil is just like this one, which will fit underneath there nice. This was my very first attempt years ago. Well, actually, wasn't that? Yeah, it was a couple of years ago, I think, of making a Sky Collection type pancake coil. And man, did it come out crappy. It's a bifilar. But as you can see, I mean, I encased it in resin, but I didn't wind it anywhere near what you're supposed to. But I keep it around for laughs. If I could find that damn coil. I just saw it here. Anyway, let me get it going because I just want to get this thing running really quick. Just to show you guys that it runs, which I'm sure you realize that it does. But I think right after that, I'm going, because I didn't even glue this this rotor to the carbon rod. Yeah, let me find that and I'll get it going. And then we're going to work on the vertical. I'm going to bring the big beast rotor over here and I'll show you what I'm talking about. Stay tuned. Yeah, as a side note, really quick, I have not forgotten about my friend from Perpetual Motion or Perpetual Motor. Perpetual Motor, yeah. He sent me these pancake coils, these Tesla coils. This is the actual Tesla coil right here, this big one. And it is freaking gorgeous. I don't know how he makes these. I don't know if he sends out to have them made. He just designs them or he makes them himself. I'll have to do some more research on it. But I've got this huge Tesla coil, which I've got to be careful with because I don't want to damage it. And then I have these two small pancake coils. I really haven't figured out what I'm going to do with these. They're beautifully made. You've got one side connecting there and then the other side connecting there. So there's continuity. There's only 20 turns. It's really small wire. And I bet you I could get it to run one of my little maglevs, that one that runs off of that weird Hall effect sensor. Because this would take really low voltage. It could take higher voltage. I've already tried it. But it's not going to produce, at least for the types of rotors I have. I do have smaller ones though, but I'm still haven't figured out what I can do with these. If anybody's got a suggestion for this, for these small ones, or for this big bifilar Tesla coil, it has a trigger winding, and I mean, it's really cool. Let me take off this tape, show you what it looks like down here. keep the tape on though to protect the terminals. Yeah, see, it's got the trigger winding here. So these two come down here, and then it has the one connection there. Yeah, YouTube/perpetual motor. It's got a killer channel. Let me put the tape back on here. He obviously knows more about, he's probably forgotten more about building coils and Tesla coils, and yeah, he's probably forgotten more than I'll ever know. But anyway, he sent those to me, just telling me the only catch is to put it in a video. And I haven't figured out what I can do with them yet. So if anybody's got a suggestion, please let me know. I'd love to hear about it, and I'll take any suggestion if it makes sense, which I'm sure it will. The guys that watch this and gals are brilliant in their own right, make me look like a dummy. I just like to build pulse motors. The science behind it, I have a grasp, but truly not as much as most of you guys. Anyway, if you have an idea on what I can do with those, please let me know. Anyway, stay tuned so I can figure out a way to get this guy going. Wow, that runs really nice. Obviously, I found the Pancake Coil. It runs a lot truer than I thought. There's the output. Again, it's flashing on the camera, but in real life, that's at 12.4 volts. I gotta see what the speed is. Maybe I can measure it without having to put a strip on it. Let's take a quick look here. No, I need to put a strip on. There's nothing to reflect off it. This is one of those really cheap tachometers. I'll put a strip on it. Let's shut it down. Put a strip on it. Put a strip on it and see what it reads. All right. Normally I don't take you guys for the ride of this stuff, but it shouldn't take that long to put a strip on. All right. Let me see if I can get the backing off of this in a timely fashion so you guys aren't sitting there going, what the hell is this guy doing? Again, if anybody knows what I can do with those coils that I just showed, let me know. All right. Oops. Come on, don't fall, you dumb son of a bitch. It starts off a little bit rattly, but then it finds its footing. All right, let's see what we got here. It says 47. Let's see. Yeah, 4,700 RPM. It's not terribly fast, but it's also not slow either. Oops. Yeah, 47 is pretty steady at that. If I take it away and I come back to it again, 47. Let's see. Yeah. All right. It's not bad. Not bad at all. Glad I figured out what the issue was with the magnets. So now I'm better armed with that information. Let me bring over the big guy and kind of walk you guys through what I want to do. Stay tuned. So you guys remember this, right? And it's being held up by the magnets in repulsive form. So what I want to do is right here and right in there and right up there and right up there are bearings. I want to replace those bearings with magnets in the same way they are with the maglev. And so the way I'm going to do it is I'm going to use ring magnets, one right here and one up here. And then on the shaft will be smaller ring magnets that'll fit tight on the shaft. And it will be in such a way where the top ring magnet will push up against the larger ring magnet on the shaft, and the same on the bottom here, but in opposite directions. And then the whole thing will be pushing against this repulsive magnet here. So if I do it right, it should work. So yeah, it's going to be tricky. It's going to be a lot of 3D printing. I'm probably going to have to harvest because I don't think I have ring magnets. Here's my magnet collection right here. Oops, sorry. I have them all on this bar. Got tons of them. I have them other places too. But I have a couple of ring magnets that may work. Because again, I'm not going to be doing it with this rotor. It's going to be a much smaller rotor and lighter. So I have some here, which I think will work. I have these small ones here, as long as they're, I forget what it's called, diametrically magnetized, or as long as they're magnetized through the width, it should be good. If they're magnetized in the way you normally magnetize a magnet, instead of being half and half on the horizontal plane. Anyway, I've got these. I also have, oops, that's what happens. I also have these, which I believe are the same thing as those. Oh, I just cracked those. Son of a bitch. That's what I get for playing around. Anyway, I've got these and one of these. I also have some really fat ones right there. I can't use those. I have one right there and right there. That's too, the ID is too small. Let me see what I got back there. No, those are just, all right. So I can test it out just to see if the theory works with these. And then if I need to, I can order some ring magnets. But first I got to take this thing apart, which I really don't want to do. I love that thing. But because I already have this set up, I can reuse it. And actually, I can put this guy back in its vertical stand right there. Because I won't need the bearings. Yeah, so let me get thinking on this and get going. So stay tuned. So as you can see, with the top off, the two bearings right there supported enough, but it would wobble a little bit. I got to put that underneath there. Yeah. So, yeah, I'm going to have to, and again, I'm not going to use something this big and this heavy. I used inserts drilling into the acrylic rod. What a nightmare that was. And everything is 3D printed. All the spacers, except for the acrylic, obviously. But yeah, let me do some kind of a mock-up without having to 3D print new parts, maybe. All right, stay tuned. All right, as sad as it is, I got the whole thing apart. So now I have to figure out, oh, actually, it's not that hard now that I'm looking at it. I put a ring magnet here and a ring magnet here, and the internal opposing rings, or up here, it doesn't really matter. But what I should do is make holders for them, 3D printed holders with the same hole pattern as these guys. As the 3D printed bearing holders. I'll just have to, oh, that's not going to work. I won't be able to use the same hole patterns, right? Because the ring magnets, what did I do with them? Oh, here they are much, oh no, they're actually not that much bigger. So, yeah, it'll be tricky. Oops, it'll be tricky to put, trying to do this one-handed sucks. Okay. Ah, fuck that. Jesus Christ. All right, so the ring magnet will be a little bit bigger. And it looks like it might interfere with the hole pattern. Maybe not. I can do it from underneath and just put really small screws there. Bottom line is I'm going to have to print out some holders for these ring magnets. These should be good enough for the size of rotor I'm going to do, because again, I think it's going to be something in that area. Actually, it's going to be a little bit taller. It's going to be about 30 millimeters taller than that. So it'll take up a good volume of this, because I'm going to put the 3-inch bar magnets in there. So I need to print out a new rotor for that. And these ring magnets, along with these ring magnets, should work. All right, let me get designing and we will return.